I want to talk about asynchronous data processing and how that fits into how you architect your system. And specifically, I want to talk about how RabbitMQ operating as the message broker can allow for asynchronous data processing inside of your system. So RabbitMQ allows us to create queues that our system can publish to and consume from. And this creates an asynchronous path for your data to flow through because service A can publish a message to RabbitMQ that then gets published to the exchange and routed to the queue. And service A is not waiting on anything. All it does is publish it, and if you have it set to have a publish confirmation, it'll get an acknowledgement back if you have that sent. Service B, on the other hand, is a consumer of that queue, and service B is going to consume that message off of the queue and do something with it. And there's no direct connection between service A and service B. There's this intermediary step of the queue operating, allowing for that asynchronous flow of data. And this allows for plug and play of systems if you truly have them decoupled. Because service A shouldn't have any knowledge that service B exists. All service A cares about is it's sending data somewhere and it's going about its business. So it shouldn't be held up by anything happening by service B. The only tangible thing that you might see happen if service B is getting behind is a backup in the queue. And that still does not affect service A's operations. And so queues allow us to create this loosely coupled design where we can remove systems out of there and plug new ones in, all without disrupting any data flow. And the way this works is that, particularly with RabbitMQ introduces what's called an exchange. And an exchange is basically the router for your messages. So when you publish a message to RabbitMQ, you're not publishing it directly to the queue, you're publishing it to the exchange. The exchange you can think about an exchange like you would think about your home router. You know, when you're operating on the network, your router is routing you to the right IP addresses. And so you can think about an exchange as that router. It's routing the message to whatever it's bound to. And if it's bound to Q1, it's going to route the message to Q1 accordingly. And exchanges can be configured in such a way where you can create a fan-out exchange, meaning the exchange will route the message to all the queues bound to it. You can create a topic exchange, meaning a message will only be routed to the queue that correlates to the message key. So it'll have a key, and your exchange can be configured to look for a particular pattern of the key, a whole key, something of the key that will then direct it to its respective queue that's bound with that key pattern. You can create a headers exchange where it uses a header on the message frame to route to an appropriate key or appropriate queue. So if you have set on the queue to receive messages with the header test, if I publish a message up to my exchange, if that message contains the header test, it'll be routed to that respective queue. I'm trying to think if I missed one topic. There's a topic exchange, fan-out exchange, headers exchange, and direct exchange. And these exchange configurations allow us to create very robust systems. And in this topic, I'm specifically going to be talking about fan-out exchanges because I think they're very powerful. So if we have a system where we have an existing flow of data, let's say my engine's API is sending data through, it's publishing data to my exchange, it's being routed to a queue, and I have my Rust microservice consuming data off of that queue. Let's say I want to add another service into my existing system without disrupting a single thing. And I want this service to also be a consumer of that data, but it's going to do something else with that data. Let's say it's going to be a logging service or an analytics service that's going to perform some kind of operation on the data that's flowing through. We can use a fan-out exchange and bind a new queue to that exchange, and then instantly, as soon as we bind it, that data will flow to the new queue and be ready for consumption by whatever service is registered to consume off of that queue. And that in and of itself is extremely powerful because not only have we added a new component into our system with zero disruption, but we've done so in a way where we haven't created competing consumers off of a queue, but we've replicated our messages to multiple queues, and we can do different things with the same exact message. And there's a guarantee that there's a delivery guarantee that the message that is routed through the exchange is going to end up on both queues because that's how fan out exchanges work. And if we think about how this allows us to create loosely coupled systems, obviously we get the plug and play ability with a single queue, but as soon as we create more complex bindings and complex exchanges, we can really create very, very powerful systems. And you can even think about it in the form of data redundancy. If we need some kind of backup plan for our data, let's say we're dealing with, I don't know, we're dealing with some kind of data that needs to be available for one day, and we need a record of that data for that day. We can bind a new queue that all it does is act as a log for all those messages all day, and we can set a time to live on each of those messages, an expiration date that will expire at the end of the day. And so every day, not only have we created a complete backup of all the message flow, but it'll be wiped before the next day happens. And we can do all this with no code. We can do all this right inside of a RabbitMQ server. And that in itself creates a unique opportunity to create very creative and powerful pieces that can fit into our system with no deployments, no disruption to any part of our system. The only disruption that you might see is that you might introduce a little bit of latency. A little bit. Fan out exchanges are very fast, but if you do add a queue, you may experience a tiny fractional of a millisecond, and maybe a millisecond, but you might introduce a little bit of latency to that. And if you use headers exchanges and topic exchanges, depending on how complex of routing you set up, you may introduce a little bit more latency, particularly if you are routing on patterns on the topic or the key. You may see a little bit of latency with that. But I think I think it's going to be tolerable, especially for if we are truly introducing a lot more power into our system. And if we look at it like this, right? If we have two systems, A and B, and if we have system A communicating directly with system B, if system B goes down, what happens if system A tries to send system B data? It goes nowhere. It disappears. We lost our data because we're going to get some error that service is not available, and that's going to be the end of it. There's not going to be, unless we code something in the logic of service A to throw that data to some database or do something with it somewhere. We still have to do something inside the code. So if we change how service B gets that data, we have to do a deployment and we have to do something in the code, which takes time. And there's always inherent risk, especially with redeploys, because you may introduce some form of downtime. But if you already have that loose coupling in the form of a queue, you can get away with adding things and performing tests in live scenarios because you have the power of using an exchange. And this is where I really think that this is such a powerful tool that we can really use in creative ways. And I just think that the more we dig into the proper configuration of RabbitMQ, particularly with durable queues, delivery modes, making sure we're sending persistent messages. And if we start to even think about how we're going to create a Rabbit cluster, how we're going to have our nodes set up where we can have replicated queues, where we can scale horizontally our queuing, that introduces a whole new form of scalability on top of creating loosely coupled systems. Now, with that, you have to take into a couple considerations. You have to take in consideration that you now have the possibility where one queue may not be as up to date as another queue because it has to replicate to that queue. The leader node has to replicate to the child nodes, and you have to set up either federated messaging or shoveling to allow that to happen. So there's a bit of configuration you have to do, but you can do it. And you can try to do this. You can try to mess with the configuration locally. I don't know how far you'll be able to get, but you'll definitely be able to experiment up to a point. Um, but this whole thing that you can set up is going to allow you to not only have service A talk to service B asynchronously, but now you can introduce service C, D, E, F, all without disrupting any data. And if we think about if we think about a queue first design or a queue driven design, we can really begin to ask ourselves the question of, is it right for service A to directly talk to service B or service B to directly talk to service C, regardless of how fast that may be? Or should we always route the message through a queue so we can take advantage of all the benefits that come along with using a message broker? And not only do we get a better guarantee that our data is not going to get lost, but we also can get a lot of retry capability. We looked at on the channel, I showed you a demonstration of the retry policies that you can get. So if service B, let's say, tries to publish a message to RabbitMQ and something fails, we can set a retry policy where it'll try that again. And if it doesn't work, it'll try it again. But then if it doesn't work, you can set an error queue where we can send it to an error queue. And the same thing on the consumer side. If you consume a message off of that queue, and let's say our consumer fails to send an acknowledgement back, then that RabbitMQ is going to say, hey, wait a second, I don't think this consumer has gotten the message. We're going to retry. And this is built because of the AMQ protocol, RabbitMQ's implementation of this protocol. And basically, when you register an application, let's say we're going to register a application to publish a message. We're basically creating a new channel, a new TCP connection to RabbitMQ via a channel. So it's going to be a single TCP connection, but RabbitMQ makes these channels, which is basically like a virtual TCP connection overlaying the one singular TCP connection. So RabbitMQ, every connection you make to it is going to make a new channel. And with this channel, you have a consistent communication stream between your application and RabbitMQ. And that allows us to have acknowledgments. And with the acknowledgments, we can create we can get publisher confirmations. We can get, we can take advantage of implementing retry policies. And we can also get just a little bit more fine tuning of our performance by way of prefetch counts. So if you're concerned about how much data your consumer is trying to pull off RabbitMQ in one go, you can adjust the prefetch count. You can adjust there's a lot of configuration you can get. You can even, you can get really, really deep with that. And if we start to think about only communicating through queues between services, or really a queue driven design or a queue first design, whatever you want to call it, this is going to, I think, unlock so much potential and power in our systems, because now we can plug in a system anywhere we can plug in a new service anywhere inside of our system with no disruption, no new deployments happening to any of the existing system. We can get a guarantee that data is not going to be disrupted. We can get an instant log of data anywhere in our system, because all we have to do is make a fan out exchange and create a log, and it will capture a snapshot of all that data, set an expiration date for whatever we need, and then it'll clear it up itself. We can get all that guarantee. So any step we're taking to call an API, if we put a queue in front of that and route it through the queue, then we get so much more power. And all it takes is a little bit of configuration up front, but we get all that, pretty much out of the box. RabbitMQ is so fast. There is not going to be any noticeable latency if you change your system to go from service A to service B to now service A publishes to exchange 1, which gets routed to queue 1, which goes to then service B. Go ahead and test it locally. See if you notice much latency at all. But the power that you get with that, I think is going to make up for itself. And I mean, I was serious. I would really go and test this out yourself and try to get creative, because you can create some really unique solutions, because you can actually route a message through an exchange to another exchange. So if you want to have a fan out exchange that routes to queues, but then you even want to get more granular on some part of it, you can route that message to another exchange. You can bind an exchange to an exchange, and you can have that exchange be a topic exchange, whatever you want, and then you can then route a message to different queues based on some whatever the key was. You can bind it to a headers exchange and use headers if you set those in the code, and you can bind. There's just so much you can do, and I like this approach because what I was saying, it not only gives us an instant snapshot of the data to any part of our system, but it also gives us a guarantee of data retrieval and you know, data making its way to its destination. But it also gives us um, another. It also gives us an instant backup. It gives us an instant backup because all we have to do is if if our code doesn't if something happens to our data, let's say I don't even know, like somehow our data got lost when service B was consuming it off of the queue. Like let's say service B consumed the message and it already had sent the acknowledgement back, so that means RabbitMQ has removed it from the queue. Service B is doing something with it, and then service B goes down. It goes down out of the blue and doesn't come back up. That means that message is lost. But it's not lost if we have another queue that has the data there. And so it's hard to counter that. And what you can do, I mean, you can do this a number of ways, but if you have a setting that allows you to control what queue you connect to, you can do this with a database value. You can do this with some kind of let's do it with a database value. Let's say you have some settings table just to keep it easy, right? Uh, let's say you have a consumer setting that allows you to change a queue. You can toggle that, and you can toggle between both queues, and instantly, if you have a check for like what queue you're doing it for, you're trying to get a message from, you can change that. Now you might have to do like it really depends how you implement that. I think we would have to really think about that before I start talking about it. But you can configure that, and you can configure some form of backup between both of those queues. And I think that is so powerful because that not only it gives you a snapshot to any part of your system, and there's no worry about any backup because you can just have an expiration date and it'll go away. And that to me is huge, and that to me is very powerful. And I know that you can add logging, right, to see data, but that's a log. That's not live data you can go back and use. This is. And so maybe we'll do this on the channel. Maybe we'll have like a demonstration of this, but I've already really showed all the components of how this would work. And you can go and test this yourself. Just pull down the image for RabbitMQ, run it locally, connect a .NET web app, and then just start messing with the settings. Just start playing around with it. And I think I really think that there's a lot of untapped potential using this technology and using this in specifically RabbitMQ. I think that there's a lot more we could do with it. I think there's a lot of creative ways that we could use it to make even more powerful systems, but also make systems that are just have a better guarantee that our data is getting to where it needs to go. And so, yeah, that's really all I want to talk about today. We could talk about this for probably another hour. We could just throw ideas around. One idea that um, I'm trying to figure out, I'm trying to figure out how to make a custom plugin for RabbitMQ because it's written in Erlang. I don't know Erlang, so I'd have to learn that a little bit. But I want to do that next. I really want to make my own plugin for RabbitMQ. Um, I got some ideas for that. But yeah, if you have any more thoughts about this, there's some other things I've been wanting to experiment with about. But yeah, system design. I'm telling you, system design is so important. It's so important, and I think the more we study it and the more we try to understand it, I think the more creative solutions I think we're going to find for problems. And so, yeah. Anyway, that's all I got today. I'll see you in the next one.